Hello learners. Let me ask you something simple. When you stand in line at the school canteen, isn't it always first, second, third, fourth? That order is not random. It's exactly what we call a sequence in mathematics. Formally, a sequence is just an ordered list of numbers arranged according to a specific rule. We denote the terms as a sub 1, a sub 2, a sub 3, and so on up to a sub n. The little subscript tells us the position of each term. Sequences can be finite, meaning they stop at some point, or infinite, meaning they go on forever, just like an endless queue at exam fee submission. So in short, sequences bring order to numbers. Now let's see some fun examples. Think about your family tree. You have 2 parents, 4 grandparents, 8 great-grandparents, 16 great-great-grandparents. The numbers double each time. That gives us a sequence: 2, 4, 8, 16, and so on. Or take 10 divided by 3. The decimal expansion gives 3, then 3.3, then 3.33, then 3.333, and it keeps going. That's an infinite sequence. Another simple one, even numbers. Its general rule is a sub n equals to n. For n equals 1, we get 2. For n equals 2, we get 4, and so on. Similarly, odd numbers have the rule a sub n equals to n minus 1. And then the superstar Fibonacci sequence. Start with 1 and 1. Each new term is the sum of the previous two. So 1, 1, 2, 3, 5, 8, 13. And yes, it appears in sunflowers, pine cones, even galaxies. Nature loves sequences. Now, let's make things practical. Suppose I ask you the 24th even number. Are you going to list them one by one? No way. We use the general term. For even numbers, the rule is a sub n equals to n. So, a sub 24 equals 2 times 24 equals 48. For odd numbers, the rule is a sub n equals to n minus 1. For n equals 10, a sub 10 equals 2 times 10 minus 1 equals 19. But here's the catch. Not every sequence has a neat formula. For example, prime numbers 2, 3, 5, 7, 11. They don't follow a simple rule. So the general term, when available, is our shortcut. It takes us straight to any position without listing the entire sequence. Here's a big idea. Every sequence can be thought of as a function. Formally, a sequence is a function f from natural numbers to real numbers. That means, put in a natural number n and the output is a sub n. For example, define f of n equals 2 and put n equals 1, we get 2. Put n equals 2, we get 4. Put n equals 3, we get 6. That's exactly our even numbers sequence again. If you plot this on a graph, you'll see dots at points like 1, 2, 2, 4, 3, 6. Not a continuous curve, but a staircase of points. So, sequences are just special functions defined on the natural numbers. Now comes the exciting twist. What if we don't just list numbers, but add them? That's when we move from a sequence to a series. Take the sequence 1, 3, 5, 7. The series is 1 plus 3 plus 5 plus 7 equal to 16. That's a finite series. But if we keep adding forever, like 1 plus 1 half plus 1/3 plus 1/4 and so on, we get an infinite series. To avoid writing all terms, mathematicians use sigma notation. For example, sigma from k equals 1 to n of a sub k equals a sub 1 plus a sub 2 plus ... up to a sub n. And if we take sigma from k equals 1 to 5 of 2k, it expands into 2 plus 4 plus 6 plus 8 plus 10. Compact, neat, and powerful. Let's test our skills with a solved example. We are given a sub n equals bracket open and minus 1 close times bracket open to minus n close times bracket open 3 plus n close. Now, let's find a sub 20. Substitute n equals 20. So, a sub 20 equals bracket open 20 minus 1 close times bracket open 2 minus 20 close times bracket open 3 plus 20 close. Simplify step by step. 20 minus 1 is 19. 2 minus 20 is negative 18. 3 plus 20 is 23. Multiply. 19 times negative 18 times 23. That equals negative 7,866. So, the 20th term is minus 7,866. Direct, precise, and exam ready. Let's wrap it up. We learned that a sequence is an ordered list of numbers, finite or infinite, defined by rule. The general term a sub-n lets us jump straight to any position. A sequence can also be viewed as a function with natural numbers as input. A series is the sum of sequence terms, finite or infinite, often written with sigma notation. So, sequences give us order, and series give us accumulation. Together, they form the backbone of much of higher mathematics. And in our next video, we'll dive deeper into sequences, exploring special types like arithmetic and geometric progressions. Stay tuned.